In today's video, I would like to introduce a very nice problem of Nordic Mathematical Olympiad, edition 1994. Here is the following information. Find all positive integer. We have n is strictly inferior than 200. We have this setup, n square plus n plus 1 square is a perfect square. Okay, so our goal, we are going to determine the n as a positive integer in order to have this expression as a perfect square. Okay, this is very nice and straightforward problem, but it's very tricky. Okay, if you would like to give the try to this problem prior get into the solution, just go ahead, pause this video when you come back to see the full solution. Okay, now let's get started. So we have this following information. We are saying this expression is a perfect square, which means this one, it can be written on this form, x square, like this. Okay, now we are going to divide this one into two cases, when we have n as an odd number and when we have n as an even number. So we are going to check first with the odd number first, because odd number, it can help us better than even number. Because before doing that, I'm going to check the parity of this x first. One of these numbers is a even, but we don't know this one is a even or this one. If n is a odd, okay, if n is a odd, we know one of these terms must be odd, but we don't know which one is a odd. Okay, but since we know n is a odd, which means n square is a odd, but n plus 1 is a even, which means n plus 1 square is a even. This one is strictly telling us what's the parity of x square. X square is a odd, because even plus odd is giving us odd. Okay, next up, I'm going to move over this term to the right hand side of this equation to see what's giving us. Okay, so we'll have n square equals x square minus n plus 1 quantity square. If you take a look at this expression, this expression is written on the form of the difference of the squares. Now I'm simply going to factor out this one on the form of the product, which is x minus n minus 1 factor x plus n plus 1. Okay, now this term is an odd, and also this one is an odd, because we know the left hand side of this equation is an odd, which means the right hand side of this equation must be odd as well. Going through this one in details, so we know x is an odd, n is an odd, which makes this one even, minus 1 makes it odd. Okay, also this term x is an odd plus odd is given as even, plus number 1 becomes odd. Okay, on the other hand, this term and this term have the same parity. Okay, whatever this one is, this one has the same parity as this one. We know this term x minus n minus 1 is strictly inferior than x plus n plus 1. Okay, which means this term is going to take the small number, this one is going to take the big number. Okay, so we have only one option here. So we have number 1 and n square. This one is strictly going to take number 1, this one is going to take n square. Okay, I will have an equation, so we'll have 1 equals x minus n minus 1, and also n square equals x plus n plus 1. This one is taking odd, this one is taking odd, and also we know this one is smaller than this one. So because we have only the positive numbers, since x square is taking the whole thing, which means x is bigger than this one, which means the difference of this term is positive. Okay, so this one is positive. Now I'm simply going to solve this equation. So I'm going to extract x from here. I will have x equals n plus number 2. As I'm taking minus 1 to the left, it become 1 plus 1, which is 2, plus n. Okay, so I'm going to take this found fact and insert it into the second equation. So which means I will have n square equals n plus 2 plus n plus 1. I'm going to calculate, I'm going to simplify this expression. N plus n is giving us 2n plus number 3. Okay, now I'm going to move over 2n plus 3 to the left hand side of this equation. I will have n square minus 2n minus 3 equals 0. Now I'm going to calculate the discriminant of this one, which is delta. delta equal 2 square, delta equals 2 square, which is 4, minus 4 times is multiplied by number 1 is multiplied by minus 3, which is giving us 4 plus 12, which is 16. 16 is the same as 4 square. Okay, so I will have two solutions here. I will have n equals minus 2, which is 2, plus square root of delta, which is 4, is divided by 2, and or another solution, you will have 2 minus 4 over 2. So this one, 2 plus 4, which is 6, 6 over 2, which is 3. But this one is negative, 2 minus 4, which is minus 2 over 2, which is minus 1. This one is arithmetic, not taken as a solution because we have a negative here, since we have a positive numbers here. This one is not going to be as a solution. So that's mean the only solution that we have, this one, n equals 3. This one is happened when we have n is a odd. Now we are going to check when we have n is a even. So n is a even. So n square equals x square minus n plus 1 quadratic square. Okay, if I'm going to factor out this one as I have before, here is a problem. If this one is a even, that's mean the right hand side of this equation is a even as well, which means this term x minus n and x plus n have the same parity. Okay, because as we know, x is a odd, n is a even, which makes this one is a odd. Minus 1 makes it even. And the same thing with this one. This one is a odd plus even becomes odd plus number 1 becomes even. Okay, the problem, we don't have enough information about this number because both are even. We don't know may contain the even factor. Okay, so we don't know much about the right hand side of this equation. That's mean we don't know also the left hand side of this equation. So how to maintain this equation, have more information about these terms? I'm going to change this equation. Instead to put n square, we are going to put n plus 1 square here. Okay, so now I'm going to erase this one and start as a beginning. Okay, so we'll have n plus 1 quadratic square equals x square minus n square. So this is the trick of this problem. Okay, this one is going to be factorized as x minus n factor x plus n, like this. Okay, so since we know n is a even, that's mean n plus 1 is a odd. Okay, this one is a odd. Since the left hand side of this equation is a odd, that's mean the right hand side of this equation must be odd as well, which means this product, these terms, this one is a odd, this one is also is a odd. Okay, x is a odd, n is a even, mix this one odd, also this one is odd. That's mean this one and this one have the same parity. Now we are free of prime factor. Okay, now we know the information about this one. We know x minus n is strictly inferior than x plus n. This one is also is a positive because x is a bigger than n, as we have this one, because x squared is equal to the whole thing. Okay, this one is simply, I will have number 1 is taking x minus n, and n plus 1 quadratic square is going to take x plus n. Okay, now the problem is almost solved. Okay, so I'm simply going to replace x with 1 plus n. So x equals 1 plus n, which means x is going to be replaced with 1 plus n is giving us 2n plus 1. I'm going to distribute this one, is giving us n squared plus 2 times n plus 1 equals 2n plus 1. Now we have a lot of cancellation here. 2n will be cancelled out with 2n, number 1 will be cancelled out with number 1. So this one is telling us n equals 0. N equals 0. If you replace n with this, if you replace n with 0, you get 0 here, you get 0 here, you go to 1 square equals x square, which is the perfect square. But perhaps this one is out of the region because we have n is strictly superior than 0 and is strictly inferior than 200, which this one is not going to be a solution. So the only solution that we have, n equals 3. n equals 3, it makes this one a perfect square. Okay, because 3 square plus 4 square, which is 16 plus 9, 16 plus 9 is 25. 25 is the same as 5 square. Okay, so you have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. We will see you next video. Bye.